Hello everybody, welcome here to another video by JFB, and in this video we will be finally seeing how logic gates work. Isn't that great? Yeah, it's great, don't worry. So to start off the video, we're going to start with the simplest logic gate there is there. And as you can see from my section of logic gates here, there is the buffer gate, AND gate, NAND gate, NOR gate, tri-state. I don't even know what the tri-state is, but don't worry. We're just going to look at the basics: the NOT gate, AND gate, NAND gate, OR gate, NOR gate, XOR gate. That's all. Don't worry about exclusive NOR gate, but that's all. And we're going to see how all these logic gates work. Then from them, we're going to build a logic circuit adder. That's all. A circuit which will add numbers. So let's start. We're going to start with the NOT gate first of all. And as you can see, it has an input line there and an output line there. Then we're going to connect a light bulb to the output line to show that there is current actually coming out. And finally, we're going to use a switch. As you can see, the website which I'm using actually, I even forgot to. The website I'm using is logic.ly. You can Google it up, and yourself you can use it to build logic circuits. As you can see, I've not even yet bought the software because I don't even build circuits so that much. They're not really that important to programming. They're just there to help you in some concepts in programming. So now, let's start. Let's connect this switch to this NOT gate. The switch is connected to the NOT gate, and we're going to connect the NOT gate to the light and check what happens. Why is this happening? I haven't even turned on the switch, but the light is already on. If you can remember from our previous lessons, or in case you didn't watch the lessons at all, the NOT gate only gives an output of 1. And in this case, 1 is actually the light turning on. That's when we have 1 to show that the light has turned on when its input is 0. How is that even possible? Don't worry, engineers knew how they built this. So the input line for the NOT gate is currently 0. There's no current flowing through here. And by the way, current is represented by this blue line, and that means there's no current flowing through into the NOT gate. There's only current flowing out of the NOT gate. And that current is the same current turning on this light bulb. What about if we turn on the current now? Check out what happens. We turn on the current goes into the NOT gate, and the NOT gate does its thing. It produces an output of 0. So it's given an input of 1 here, which is the current, and itself, by its rule and how it works, it produces an output of 0. That 0 can turn on the light bulb, and there we have it. The light is off. Let's move on to the next logic gate. So we can clear out the canvas like that, press the delete button, and it's gone. The next logic gate we'll be looking at is the AND gate. There you have it, an AND gate. So an AND gate obeys the principle whereby if both of its inputs are 1, it will give you an output of 1. If one of its input is 0, it won't give any output. That's how it works. So we connect a light bulb to see when we give the inputs, and a switch, and another switch. Then we can finally connect this to the input line there, an input line there, and an input line there. The NOT gate by now should have turned on, but this is a different logic gate, the AND gate. So let's give it an input of 0, 0. What's an input of 0, 0? Me not flicking the switches at any time or anyhow. I've just put it at 0, 0, and nothing's going into the light bulb, and nothing's working. No current is flowing through the AND gate, and no light is turning on. Let's give it an input of 1 here. What happens? Still nothing. The light is still off. Nothing's working. Okay, now let's give it an input of 1 here. Still off. Nothing's working. What's going on? Why is it not working? Because the AND gate requires 2 inputs of 1 in order for it to work. Finally, let's give it an input of 1 and an input of 1. And boom shakalaka. The light is on. Because the AND gate, by its structure, works when both of its input lines are 1. That's all there is to it. Let's move on to the other logic gate, which, my friends, is the OR gate. So the OR gate, unlike the AND gate, it only needs an input of 1 at any of its inputs, and it will give you an output of 1. That's all. So our trusty light bulb there, and switches, 2 switches, because it requires 2 inputs there. Then now finally we can connect this. So it goes there and it goes there. Unlike the AND gate, the OR gate will turn on when either of its input is 1. Either of them or both of them, it will turn on. That's all. So currently I've given it 0 input, so 0 input here, 0 input there, and the OR gate is off. The light is not on. So let me give it an input of 1 here and check. It's on. The light is on, meaning the OR gate is obeying its structure, like how its structure is built. Simply, when one input is 1, it will give an output of 1. What about if I switch off this input line and switch on the other input line and check? The OR gate is on again, simply because every time it's given an input on either of its input line, it gives an output of 1, which one is turning on the light. What about if both of its input lines are on? And there you have it. The OR gate still turns on the light because it obeys the structure. When either of its input is 1, it will give you an output of. The difference really comes in with the exclusive OR gate, which is like the OR gate, but it doesn't turn on when both of its inputs are 1. Let me show you how the exclusive OR gate works. So we'll now go to the exclusive OR gate. The exclusive OR gate, here comes the exclusive OR gate. There. So in the video I said you can leave a gap there and all that, but it doesn't really matter. As long as you are representing the exclusive OR gate, your teachers or whoever is looking at your work won't care. So there's a switch and there's another switch. Now let's look at how the exclusive OR gate actually works. So connect there, we connect there, and we finally connect there. For the exclusive OR gate, it emphasizes on difference. When both of its inputs are the same, it won't turn on. No matter what, whether its inputs are the same on 1 1 or they're the same on 0 0, it won't turn on. And as you can see, this input line is 0, this input line is 0. And what do you think will happen? It won't turn on because simply both of its inputs are the same, only when they're different. So let's make one different. There it is. The exclusive OR gate turns on the light bulb because the inputs are different. What about if we switch off this input line and turn on this other input line? And there you have it. The exclusive OR gate is still on because its inputs are different. What about if both inputs are the same, but this time with 1 1 on both inputs? And there you have it. It's off. Simply because the exclusive OR gate wants its inputs to be different in order for it to turn on. That's all. That's all there is to it.